In this video, we're going to be talking about the linear programming project that we'll be doing all week in class. You'll be working in your groups of 4 as well as doing one problem individually. It is important that you have your rubric printed off. You will want to follow this rubric in order to get the best grade possible on this project. It is going to be counted as your test for this unit. So you're going to have class time to work on this, and if you don't get it finished in class, it is your responsibility as a group and as an individual to get this done on your own time. So I'm going to break down some of the pieces of this and go through an example with you guys in this video. You're going to want to take notes so that you can follow this exactly. The problems are going to be different, of course, but the process is all going to be the same. So if you look at the rubric, the first thing is vocabulary. So there is a list of words here that you're going to want to pause the video and take a minute to write down. These are all words that I'm going to have you write a definition for, and you need an example in a foldable format. A foldable can look like many different things. You can decide as an individual what you want your foldable to look like. You can Google what foldables look like for vocabulary words, but just make sure that your foldable includes the definition and an example for each one of these words. If you want to, you can add more words to the list of words that you come across that you don't understand what they mean. It's only going to help you, not ever going to hurt you. This part of the project is individual, so when you turn in the project, each person must have a vocabulary foldable with all of these words. So this goes towards your individual grade, and so it is mandatory that every single person has a foldable. So you will be given 2 optimization problems, one to do as your group and one to do as an individual. So during class, I'm going to give you time every day to work on this, and so as a group of 4, you need to decide, okay, today we're going to work on our group optimization problem, where tomorrow we're going to work on ours as individuals. So now I'm going to go through an example of what one of these optimization problems is going to look like and what you need to do at each step. So here's an example of an optimization problem. You probably want to pause and write this one down so that when you go back to your notes, if you get confused on the project, you have a better understanding of what to do. So this one says, I want to hire you as my consultant. Here's the problem. I manufacture 2 types of pens, an elaborate rollerball pen and a regular ballpoint pen. The rollerball pen supplies cost me $15 and the ballpoint supplies cost $7. The rollerball takes about 0.85 hours to make, while the ballpoint pen only takes 0.75 hours. I have a total of 20 hours per month to work and a total of $300 to spend on supplies. If I make $75 each on a rollerball pen and $45 on each ballpoint, how many of each pen should I build in order to maximize my profits? So this should look very similar to the problems that we were doing last week, where we took a real-world problem and we were building equations and inequalities from those problems. So like the problems last week, the first thing that we need to do is define our variables. So we look at the problem and we see, what are we interested in? What are our unknowns? What are we trying to figure out? And we are trying to figure out how many of each pen I should build in order to maximize my profits, correct? So there's 2 types of pens, thus there's 2 variables. So we're letting X be the number of rollerball pens and Y be the number of ballpoint pens. Now that we have defined our variables, we need to find the relationship between our variables and write a system of inequalities. So we need to look in our problem and see what 2 topics or what topics we're talking about in the problem, because if we have 2 variables, we know we at least have to have 2 equations or inequalities, correct? So let's take a look, and in the problem I see that we're talking about money, right? And we're talking about time, hours that it takes. And that's what I see. Those are the two main topics that stand out to me. So the first equation that we want to talk about is about the money. We want to talk about the money. So rollerball supplies cost $15. So if we want to write this, we know that X is the number of rollerball pins, right? So $15 per rollerball pin, right? So 15X plus a ballpoint pen costs $7. So we've got $7 times the amount of ballpoint pens. And we have a total of $300 that we can spend on supplies. So ask yourself, does that mean that we can spend more than that? No, we can't spend more than that, but we can spend less than that. So we're going to make this less than or equal to $300 because we can spend less, but we definitely can't spend any more. So $300 is the maximum, but we can spend $300. So that's our first equation, or inequality. So now we need one more, and our other topic is about time. So in this sentence, it says it takes 0.85 hours to make a rollerball pin. So we'll take 0.85 times the number of rollerball pins, right? Make that point a little bigger. Plus, it takes 0.75 hours, so 0.75, for the number of ballpoint pens, which is our Y. Okay, then we look at the total amount of time that we have. So it says I have a total of 20 hours per month to work. So a total of 20 hours. So we can spend no more than 20 hours. So we can spend less than or equal to 20 hours. And there's one more thing that I want to think about when I'm looking at my situation. So we have X is the number of rollerball pens and Y is the number of ballpoint pens. And something that we tend to overlook is our domain and range for these. So does it make sense for us to have a negative amount of rollerball pens? Can we unmake something? No, that doesn't make sense, right? So we need to make sure that we have our domain and range for these variables. So if X is the number of rollerball pins, we know we can't have any less than 0. So that means that X must be greater than or equal to 0. And the same thing goes for the number of ballpoint pens. We can't have a negative amount, so Y is greater than or equal to 0 also. That does mean that we can have 0. We could only make rollerball pens if that's what's going to make us the most amount of money, or we could only make ballpoint pens if that's what's going to make us the most amount of money. So we can have that they are equal to 0 also for that reason. So now we have our system of equations. Like I said before, if we have two variables, we need at least 2 equations, and we just happen to have four here because we have defined our domain and range. So we have defined our variables, we have written a system of inequalities, and now it's time to graph this system of inequalities. When you will be graphing, you're required to do a rough draft, a handmade rough draft of your graph. So you will have a graph piece of paper and be graphing all of your equations on that. And then I will also show you a program that you can do it on the computer to get more exact numbers also. So you will be having 2 graphs, a rough draft and a final draft. Here I have graphed all 4 of the equations, or inequalities, and it looks like a crazy mess. And so we're going to have to go ahead and get rid of the spots that not all 4 colors are in. Once you figure out where the overlapping colors are, you're left with this region right here in green. And you know that the intersection points of all of these lines are right here, right here, right here, and right here. This green region is what is called the feasibility region. So it's all the points that are in here that would even make these system of inequalities work somehow. And these points right here are called the vertices. And these points are the most important points because these are the points that will either maximize or minimize our optimization problem. Since these vertices are the most important points, we need to actually figure out what their coordinates are. And that is our next step, is to find the coordinates of the vertices of the feasibility region. Now, finding the coordinates of the feasibility region is where we put together everything that we've learned over the last couple weeks to find our solutions. That's what we're talking about. We've been talking a lot about solutions, what the solution to an equation is, what the solution to a systems of equations is, what a solution to an inequality is, and what a solution to a systems of inequalities is. And that's where this all comes in. So in order to find the solution or find the coordinates of this feasibility region, we have worked on a couple of different ways. So we can do graphing, where we use our calculator to find the intersection point. Substitution, which was the video from last night. Elimination, which is going to be your video tonight. Matrices, which you're also going to learn. And then also just by looking at the table. So if you looked at, or you graphed on your calculator, and you looked at the table of values for each one of the inequalities to see where they have an overlapping coordinate point that is the same. So there's many different ways that you can go about finding these coordinates, and as you can see in the rubric, you have to use at least 4 of them, or you have to use 4 of them. So you have to use the table, the graph, you can use your calculator for that. You have to use one way of algebra. I don't care if you use substitution or elimination, whatever you like best, and you have to use matrices. So if we look back at our graph, when we're trying to find our vertices, so you pick one. Pick one first and say, I want to find this vertice. Clearly this one is at 0, 0. So we can go ahead and just mark this one as 0, 0. And then let's go ahead and take a look at another one. So let's pick this point right here. And I want to say, okay, what 2 inequalities or what 2 functions is this the vertice of? So we've got this one right here, which this is the graph of this equation right here, this inequality. And then we have our y-axis, which is x equal to 0, right? So we've got x is greater than or equal to 0 because we had to go this way. So we'll take these 2 equations and use one of the methods. Use either by finding the intersection on our calculator, or substitution or elimination. For this one, I feel like substitution is probably the easiest. So we'll take our 2 inequalities, and if you've noticed, I went ahead and turned them into equals because it's easier to deal with them if we're dealing with them just as a line, because we're looking at the intersection of the 2 lines, not necessarily the feasibility region in between them. So we'll turn them into equals. And since we have the x is already equal to 0, we just need to figure out what y is, right? So we can substitute x equals to 0 right here, and we'll get, let's go ahead and work this through. So if we have 0.85 times 0, right, because x is 0, plus 0.75y equal to 20, this right here is just a big fat nothing, and we are left with 0.75y equal to 20. So in order to get y alone, we need to divide by 0.75 on both sides. And we are left with y is equal to 26.6 repeating. So that's our coordinate right there. It's going to be our x is 0, and our y is 26.6 repeating. And we always want to double check that the point actually makes sense on the graph. So if we look at our point right here, does it look like y is about 26.6 repeating? I would say so. So that actually makes sense. That's a super important just visual check to make sure. So then we'll label this point. X is 0, right? 26.6 repeating is our y. Okay, we have 2 of the problems done. Boom, I love it. All right, now we have 2 more coordinates. So we can take this coordinate right here. And we'll ask ourselves again, what 2 lines creates this intersection? And we have this one right here is this equation, and this one right here is this equation. So we're going to take those 2 equations and go ahead and solve again. Again, if you'll notice, I went ahead and changed my inequality signs to equal signs because we're looking at where the 2 lines themselves intersect. So that's why we can make them in equals instead of a greater than or less than inequality. So for these 2 equations, you can go ahead and use any form that you want to find the intersection point. And honestly, for me, I like using the calculator because it's quick and easy, and you can use it on the ACT, so it's beautiful. So when you find their intersection point, it's approximately where x is about 16 and y is about 8.5. Okay, so let's go ahead and look and see if that makes sense. So we're looking on our graph to make sure that that makes sense with what this point actually looks like. And our x is about 16, that's true. And our y is about 8.5, so that looks pretty good with what our graph looks like. So I'll go ahead and label that point where our x is 16, our y is 8.5. Okay? And then we have 1 remaining point, and that's this one. And so I ask myself again, what 2 inequalities or equations is this the intersection point of? So we've got this line right here, which is our x-axis, or y is greater than or equal to 0, right? This is our y equals 0 line. And this equation right here, this line right here, which also corresponds to this. So now we're going to take both of those to find the intersection of this. Okay, so substitution works really well with this one because we already know what y equals. We already have one solved for y. So let's go ahead and follow these steps. So we can bring down 15x plus 7 times 0, because our y is 0, equals 300. We'll bring down 15x. 7 times 0 is a whole lot of nothing, so equals 300. We divide by 15. And we get that x is equal to 20. Okay, so now our point here is x is 20, y is 0. So let's go back to our graph and make sure that that makes sense. So we're looking at our graph, and our x is supposed to be somewhere around 20, so that looks about right. So x is 20 and y is 0 because we're not going up or down from our x-axis. So beautiful. So now we have identified all of our vertices. So now we go back to our steps of linear programming. We've defined the variables, we've written a system of inequalities, we've graphed that system of inequalities, we have found the coordinates of the vertices of the feasibility region, and now we need to write a linear function to be maximized or minimized, because the whole point of this is optimization problem, right? And we want to maximize or minimize our profits or our amount of something. So that's the whole point of this, is to maximize or minimize something. And that something in our specific problem is the profit. So we go back to our original problem and we look at the question that's being asked. And this question is, if I make $75 on each roller ball and $45 on each ballpoint, how many of each pin should I build in order to maximize my profits? So based on this, we go ahead and write our equation. We'll say our max profits equals 75 times the amount of roller balls that we make plus 45 times the amount of each ballpoint pen. And now we have our function to be maximized or minimized. And now we go to our next step. So we just did number 5, we wrote a linear function to be maximized or minimized. And now we need to substitute the coordinates that we found in number 4 of the vertices into the function that we just created in number 5. So now we're going to go ahead and take each one of our points, our intersection points. We've got 4 of them, and we're going to plug each of them individually into our profit equation. So for the first one, we get P equal to 75 times 0 plus 45 times 0. And we're left with P equals 0 plus 0, P equals 0, so no profit. For the next one, we plug in our points, so P equals 75 times 20 plus 45 times 0. That would be us making 20 rollerball pins and 0 of the ballpoint pins. And we get that P equals 75 times 20 is 1,500 plus 0. We're left with P equal to 1,500. So that would be a profit of 1,500. Then we go on to our next. We take P equal to 75 times 0 rollerball pins plus 45 times 26 and 2/3. Does that make sense? No, not really. So we're going to have to go to 26 because we can't make 2/3 of a pin. So we'll go to 26. So 26. So we get P equal to 0 plus 45 times 26 gives us 1,170. So P equal to 1,170. So that's a profit of that much. And then we'll do the last point. So we got P equal to 75 times 16, 16 rollerball pins, plus 45 times, again, we have 8.5. Can we make half of a pin? No, we cannot make half of a pin. So we'll round down because we can't clearly round up. It doesn't make sense in this situation. So 45 times 8. And we get that P is equal to 1,200 plus 45 times 8, which is 360. We add those together and we get 1,560. So that gives us a profit of 1,560. So we go back to our results and we just substituted the coordinates of the vertices into the function. And now we need to figure out our answer. So we have to select the greatest or least result. And in this problem, we were asking about the maximum profits, right? So that's going to be our greatest because maximum is the greatest, right? And then we need to answer the problem. So we look at what our vertices gave us for our profit, and we find the greatest amount. So our greatest amount is going to be where P was 1,560. And that correlates to these 2 points right here, correct? So that's going to be our maximum. So when we're answering the problem, we need to say that we need to make 16 rollerball pins, because we have our X is 16, so 16 rollerball pins, and 8 ballpoint pins, because that gives us a maximum profit of 1,560. So when we're answering these problems, we need to make sure we're answering in complete sentences because real-world problems have a context, and just random numbers, if you just said 16, 8, that's not going to make sense. We have to actually put it in the correct context. So in order to get the maximum profit, we need to make 16 rollerball pins and 8 ballpoint pins. This gives us a profit of $1,560. So this is basically what you're going to do for your problems. So you're going to do one of these all together as a group, and then you're going to do one on your own. There are a lot of steps, but definitely go back and write down all of the steps to make sure that you're going through every single step. I hope you took really good notes on this example. Don't be afraid to ask questions when you're in class, but I want you to rely on your group and rely on your notes and really make this project your own. You'll be given your problems tomorrow in class, and I will let you know when they will be due.